So good morning, everyone, and a warm welcome to this Bioeconomy Cluster Builder webinar focusing on biotechnology applications in water and wastewater management, held in conjunction with Scottish Water Horizons. My name is Kim Cameron. I'm part of the business engagement team at the Industrial Biotechnology Innovation Centre, and I'm delighted to host today's session. Before we dive into the main body of today's webinar, I'd just like to run through a few brief housekeeping points. So everyone's muted throughout the webinar, but please do use the question and answer box for submitting any questions you have for the speakers. We'll have a dedicated Q&A session after everyone has delivered their presentations. The webinar is being recorded, and we'll share a copy of the recording to the Bioeconomy Cluster Builder past event webpage shortly after the session runs. So turning now to think about this morning's agenda, we'll be together for around 90 minutes. I'll begin shortly with a brief introduction to the Bioeconomy Cluster Builder, and then I'll hand over to Greg Adams from Scottish Water Horizons, who'll be outlining their capabilities and a programme they're running to support access of their facilities. Following this, we'll have some examples of case studies demonstrating applications of biotechnology in water and wastewater management from some of the organisations that have worked closely with Scottish Water Horizons in the past. And then, as I mentioned, after that, we'll have the opportunity for you to put some of your questions to the speakers. So we should wrap up around 11:30. So the Bioeconomy Cluster Builder is an ongoing initiative delivered by the Industrial Biotechnology Innovation Centre, and it has three broad aims. The first being to raise awareness of the benefits and applications of biotechnology, and we do that through a series of events like today's. And next, we connect people and resources to support the development of new value chains using biotechnology. And lastly, we encourage the use of Scotland's bioresources. So these are essentially the raw materials that are used for biotechnology processes. So just a summary of the types of activity that we engage in. As I mentioned, we run a series of online and in-person events like today's. In the past, we've looked at areas including chemical manufacturing, textiles, and construction. And as I mentioned, you can find recordings of the Bioeconomy Cluster Builder events on the past events page on our website. And we also convene focus groups and round tables of key stakeholders to help companies overcome specific innovation challenges. And as I mentioned, we provide support in overcoming supply chain issues, including those around feedstocks for biotech processes. And we use the bioresource mapping tool to do this. This was a tool developed in conjunction between iBioIC, Zero Waste Scotland, and Scottish Enterprise. And it provides reports about locations and quantities of these historical risings of these feedstocks across Scotland. We attend third-party conferences. Most recently, we were at Chem UK, the Chemical Supply Chain Conference. And this is essentially about meeting organisations on their own turf to discuss with them the benefits and applications of biotechnology and how they could apply it in their manufacturing processes. And a big part of what we do is about making connections. So we make introductions and help encourage collaboration between different groups of stakeholders. Our web address is down in the bottom left-hand corner there if you want to find out a bit more about what we do. And so support available through the BCB, as I say, we have an extensive network and we can offer connections to stakeholders across that network to help companies overcome specific challenges. And following on from that, as I mentioned, we can convene these focus groups and round tables to look at particular challenges. We also offer signposting to funding and investment opportunities from a diverse range of sources. And lastly, as I mentioned, we have information about potential feedstock supplies. So that's all from me. I'll hand over now to Greg, who's going to tell you a bit more about Scottish Water Horizons, and then we'll hear from each of our case studies in turn. I'll introduce them as the time comes. So Greg, I'll just stop sharing and I'll hand over to you.
Thanks, Kim. Yeah, thanks for hosting us again. So I'm Greg Adams. I'm the team manager at the Scottish Water Horizons Development Centre. Just to give a bit of context on who we are as Scottish Water Horizons. So we're a wholly owned subsidiary of Scottish Water, and we aim to harness the assets within the Scottish Water core business to turn a profit and meet our net zero goals, our climate goals. So as you can see on this graphic, we've got a number of different business streams, from bioreactors, producing energy from food waste. We ship water to the shipping companies at Aberdeen Harbour. We work with housing companies to design and sort of manage the wastewater and water assets on new housing schemes. We have a number of biomass boilers on our sites to reduce our carbon footprint. As one of the largest electricity users in Scotland, we've got a large range of energy reducing systems, such as, again, down in the bottom corner, we've got solar panels, we've got battery systems, we supply low carbon and low cost heating to housing schemes and businesses taken from heat from the sewers, and ourselves specifically, what I'm going to be talking to you a bit more today, is our development centres. So our development centres, we, as it says, harness the Scottish water assets there to drive innovation in the water and the wastewater sector. We have two live water and wastewater, sorry, I've said water and wastewater quite a lot today, assets which are on a live treatment works, where you can tap in to test your products on a real life situation rather than using a lab based testing. So this contributes to the Scottish Government hydronation ambitions. We aim to foster cross-sector collaboration and knowledge exchange. So this is a key partnership with the Institute of Biotechnology, having Bioeconomy Cluster sessions like today. And as I said, it's managed through Scottish Water Horizons on Scottish Water-owned assets. So our key sectors is, obviously, we've got the water industry and the wastewater industry is our focus. It's what we specialize in. However, we can also cater to biotechnology, pharmaceutical, construction, food industry, the drink industry. So Jonathan, who you'll hear from a little bit later on, he came to our site at Bo'ness and brought his own feedstocks from the fishing industry. Sort of built an IBC load of fish waste in our car park to be used as the feedstock for his trial. We've had other food and drink products. We've had pot ale trials from the whiskey industry. So we can cater to a wide array of testing parameters if we've got the space for it, and we've got the operators who are always keen to have a new toy. So as our vision is really innovation in the industry. We're looking to, with our development centres, we're trying to become a gateway and a vessel for new technologies, businesses, academia, and collaborations like the Hydronation Chair and Biotechnology Innovation Centre, really to address current problems. There's always problems, and the future problems such as climate change, water scarcity, resource limitations, and problems that we've not even thought of yet. We want to be at the forefront of tackling these issues and providing a solution. So at both our centres, the real gain for what we offer, as I said, they're on a live treatment work, so it is 100% real day-to-day effluent and raw water that's coming in to be tested on. We've got technical expertise, we've got really great relationships within Scottish Water, process science teams, research and innovation teams. We have access to UCAS accredited scientific services. So on our sites, we have bench testing capabilities, but we also have the facility to send samples to the Scottish Water laboratories to get official sample results, which can be tested against, as I said, it's a UCAS accredited. We've got a platform for students to gain hands-on industrial experience, so we host regularly site visits. Depending on what we've got on the site, we can host academia, we can host businesses that are interested in what we've got going on. And we also regularly have, as I say, experts from Scottish Water that are trying to tackle these problems to come and look at the trials that are going on. So it's a bit of internal advertisement specifically to the people who have got the purse strings to make the decisions. We've got a culture of knowledge sharing and co-working, so we again regularly host sessions with industry partners, and we've got wealth of experience we've got a number of operators, we've got project coordinators, and we've got a great marketing team at Scottish Water Horizons, so you won't be short of support if you come to our sites. So we'll delve a bit and specifically into each site. As I say, we've got two. We've got a wastewater development centre located at Bowness, about 25 minutes outside of Edinburgh. As I say, it's got a live effluent stream, so you can test right from the raw sewage coming in, post screening, post settlement, and then right through to the final effluent. We've also got a number of redundant assets on site that are available if you require to use them. We can set up a new project specifically tailored to the needs of the trial. So I'm going to go into see if this works into a 360 view of the testing hall. Hopefully, yeah. So this is our testing hall at Bowness. So we've got three bays internally, and as you can see at the back, you've got the live effluent streams which you can tap into. It's really just a plug and play valve system, and we've got 2-pin and 3-pin sockets. We've also got external space for if you've got a bigger bit of equipment, it can fit outside in the car park, and we've got the feeds come right to the outside. We've also got around the other side a dedicated inlet testing area. So this is the inlet flow, and we've got a pipe that tees off that you can again just plug and play into a flange there for screenings and fine screening technologies, grit separation technology, and also if you're looking to test a pump on some of the chunkier sewage that comes in at the front end. We also have access to a pilot sequencing batch reactor. So it can be used as a single consecutive cell, or it can be used as a double cell for whatever treatment you're looking to try. We've had people use it for chemical treatment additions, so likes of poly addition to the flock, wastewater instrumentation. It can be rigged up to sit on top of the reactor, and other sorts of chemical mixing technologies. We've also got some additional areas. So bottom there is post screening. So you've got your raw sewage at the top, then into your post screening. So we've got really access to an entire wastewater treatment works completely live, and can be varied for whatever flows, whatever type of treatment is required. So this is just a quick couple of examples. We've got some great speakers to talk about their time here, but there's just a couple of examples of people we've had. So Microvi, they used biocatalysts to treat the wastewater. So you can see it's quite a simplistic rig setup. They've just got buckets of containers with piping in between. So it can be a very low tech, low sort of budget trial. It doesn't have to be a huge rig. As you can see at Aqua Novus on the right hand side, they were using pot ale from the whiskey industry, and you can see they've brought their own rig from laboratory testing to plug in and use the space available. And then, as I mentioned, we've got a couple of bigger pieces of equipment. So Jacopa, a sludge machine. It's quite a big unit. It was sat outside. And then we've got Power and Water, who are also going to be speaking a little bit later on. You can see their equipment there. It was sat outside, and plugged into the wastewater stream. So moving on to our water development centre, it's based up in Garthleck, which is sort of on the banks of Loch Ness, about half an hour drive from Inverness. So it was a disused membrane treatment works. It's since been, the area has been mained out to a larger treatment works. So we've made use of this brilliant asset. It's disconnected from the public water supply. So whatever treatment you're working on, it's not going to be going into the people's drinking tap. So it's a low risk environment. You can really play about with it. There's no concerns. And it's a highland resource, so it's got a very varied raw water quality, and depending on the weather, you can get very over time. It can be quite dark as well. So you get some of the best water treatment conditions to really test out your trials. So again, I'll try into the 360 just to show the testing hall. So you can see there we've got 3 bays, very similar setup with the inlet feed. So that goes from the raw water into the membranes, and so you've got untreated and treated water that you can test on. We've got quite a big hall, and then you can see these rigs. We've got spiral membranes, tubular membranes. So it's again a very robust treatment works. Just to give you an idea of the rest of the facilities, we've also got a meeting room, which can be used if you're taking trial. You can take meetings there. You can have your lunch there. We've also got, if I go through into the hallway, hopefully, we've got a canteen in there. Not working, but so it's a really brand new asset. It's got great conditions. So you're up in the Highlands, but it's a very comfortable stay while you're there. So again, a couple of trials we've had in the past, the Scottish Water and Scottish Government combined trial to look at point of use treatment for rural water supplies. So that's essentially treating the water at the tap when you turn it on, rather than treating it externally and then having it travel long distances to rural people's houses. And then we've also had a Water Source International came across from Australia to trial out their water purification system. So you can see that there, it's got quite an intense piece of equipment. So that was trialing against the raw water quality, which I say is very temperamental, which is really the best you can hope for a trial situation, to get the biggest variation to prove your kit. Also rolling out at the Garthleck is the Membrane Training Academy. So our Scottish Water Process Science Membrane Excellence team, they're premier experts in membrane treatment. We've got a lot of membranes in the rural community in the north of Scotland. So these guys are experts. They're going to be training. They started training internally. So all of our Scottish water treatment operators will be trained up in how to use the membranes. So as I say, we've got spiral membranes and tubular membranes. So it's a very interactive training course. They go in and essentially break the system and show you every way that it can be fixed, so that you're equipped to deal with any emergency. Also teaches you about the membrane maintenance requirements, so foam ball changes, the instrumentation, and the disinfection stage post treatment. So this is going to be getting launched externally for other water treatment companies and anybody else that is looking to get trained up on membrane technology. So just some of the key benefits I'll highlight, but I've sort of touched on at our sites. As I say, it's very low risk. At Garthleck, it's completely disconnected from the treatment supply, and at Bo'ness, it goes back to the head of the works. So anything that is treated is going to get retreated before it goes into the river. So it's a very low risk. There's you're not going to cause any problems if something goes wrong or your technology doesn't work as the way you expected. As I say, it's live, 100% live conditions, comes straight off the works, and it's at a large scale. We've got insurance against any problems on site. We're also SEPA engaged with SEPA, so we've got licenses there for making sure that nothing goes wrong and is getting put out into the river. We've also got, as I say, UCAS accreditation. We've got abstraction licenses at Garthlek. Support-wise, we've got project managers in our team who can organize and manage and scope a trial, so we can really take it from an idea, or you've got a bit of equipment, straight through to a plan, a testing conditions, your lab samples. Everything can be organized from our end. We've got the expertise in that. We've got operator support, so you can either choose to run it yourself. You're more than welcome to attend site and run your equipment yourself, or you've got the option to train our operators up on your equipment and let us run it for weeks, months, however long you require it. Health and safety wise, and contract support, we're part of Scottish Water, so we've got a brilliant health and safety sort of contractual legal department. We take health and safety very seriously, so you should feel very safe on our site, and you can't expect any dodgy business. And then in terms of the comms, so our communication department at Scottish Water Horizons are very clued up on promotion, marketing, and would also be very keen post-trial to maintain a relationship and use any trial we have on site as a case study, so to promote yourselves and also promote our development centres. So after a trial, we like to keep in touch and try and give your company the best promotion to internally at Scottish Water and externally within the industry. So it's you really get your money's worth once you've trialed it. So probably the most important slide, I'm sure a lot of people have dialed in to hear about this. So this is our innovation voucher scheme. It's now live. We have set up this scheme basically in the aim to stimulate innovation, to stimulate the industry. We've put our money where our mouth is to try and get trials through the door to really drive forward the ambitions of Scotland, the UK, and get as many small companies and academias and any ideas that people have got through the works into a final solution to solve some of Scottish Water's problems and the wider water and wastewater industry, and as well, as I mentioned, the other industries that don't necessarily have to be part of water. It just has to be a useful idea that's going to come in handy. So the basics of it are we're offering 50% contribution to a trial at our facilities. So that includes the bay hire, the operational time, and the power costs. So it's open to small to medium enterprises and academia with no alternative trial funding. So we've left this a little bit vague. If you've got funding for your project but not specifically a trial, please do apply. We're quite open. It's not that strict, but it will come down to our decision. So it's at Scottish Water Horizons' discretion. And again, we're not looking for anything overly specific. In the past, we've had calls to action for a specific problem. All we're really looking for is, can your equipment or your idea demonstrate a significant or marketable improvement to a current process, or is it a new process that is better in some way? So as I say, the decision will be made between the Horizons team, and we'll look to seek expertise from the various Scottish Water experts, the departments in Scottish Water that is relevant to, if required. So it's open now. You'll find it on our website. It's open currently for roughly 6 months. We'll look at the inbox every roughly monthly to make decisions and get in touch with people. So we'll probably look to have a call to discuss the product before we enter into any contracts. So that's the innovation voucher scheme. It's quite simplistic. We're really aiming to get as many people through the door as possible, to make it worthwhile for everybody, and to try and, as I say, drive innovation in the sector and get some great products out there. So that's my email address there, and also if you go to the Scottish Water Horizons website, you'll be able to get a lot more information.
Brilliant. Thanks, Greg. That was great. A real sense of the capabilities of Scottish Water Horizons, and also good information about the two sites that you have available to access as well. So thank you. I'm going to hand over now to Sabi Pap, water technology researcher at the Environmental Research Institute at the University of the Highlands and Islands. Sabi, do you want to share your screen? And
yeah, I will try to do it. So okay.
Oh, good. Yeah, I can see that. Thank you.
You can see. Okay, so hi everyone. As Kim said, I'm Saboj Pop from the Environmental Research Institute, and I will talk today about producing biochar from sewage sludge, and to use that sewage sludge to recover phosphorus from the wastewater. This project is still ongoing on some way, and it was funded from IBOIC Feasibility Fund and Scottish Water and Scottish Water Horizon, and we had one other UK-based partner, OL2 Tech, who was like a company who's producing large pyrolysis units for biochar production, and these units are for industrial scale. So just really quickly, so what is biochar? So biochar can be produced from different feedstock. In this case, it was from sludge, sewage sludge, which byproduct, a bioresource from wastewater treatment plants, or it could be from fish farms. And then the process how we're producing biochar is a pyrolysis, which is a high temperature combustion and on the oxygen limited conditions. And the biochar is one of the final products. But we have two other phases: is the syngas and the pyrolysis or bio oil. And that's the three, like the solid gas and liquid phase from the pyrolysis. And we are interested in this project solely on the solid phase or biochar. So a little bit just about the regulation and the market perspective for a biochar. So everything is started like, let's say, a little bit more than 10 years ago in Europe, and when the European Commission funded the Strubias group. This time when this group was funded, UK was still a member of the European Union. But in the meantime, UK left. But this group is helped to develop this new European Union fertilization product regulation. And then because of this, from 2022, we have a biochar as a marketable fertilizer in the European market. That's not really included in every country sewage sludge, because sewage sludge is excluded from this regulation, but they leave the back door open for then if some country in the European Union thinks then they want to allow sewage sludge biochar to be used as a fertilizer, then they can do that. So that's the reason, for example, in Czech Republic, in Estonia or Sweden, they already using sewage sludge biochar as a fertilizer. And also the European Biochar Initiative just submitted to the European Commission like a month ago a new position paper, which we think it's going to really help to finally sort out this problem about sewage sludge biochar in Europe. So we think that in the next 1 to 2 years, it will be included in this regulation, and it will be everywhere a marketable product. In UK, we don't have any regulation for biochar, not from any cleaner feedstock. When I'm saying like cleaner feedstock, it's like, let's say, a wood chip. So we don't have regulation for those biochars, not even, and of course not for sewage sludge. There's a couple of attempts to and for example, this project has came to life because we want to push forward with SEPA and the Scottish government to allow as biochar and then the sewage sludge biochar to be a marketable product in different industrial like sectors. For example, we had this biochar quality mandate, which was published like around like 10 years ago, and then we updated this last year. We updated this document, included into this biochar quality mandate document the sewage sludge biochars, and then hopefully again this will help the decision makers to move forward the whole biochar story in the UK. The global biochar market is really an expanding market, and it looks like it's a really rich market. So it's because of many different reasons, and what I don't have time right now to explain. But example, the prediction for 2022, then the biochar market value will be around like $3 billion US. This value just 2 years ago was 10 times lower. So the prediction was then it will be around like $300 million, and now it's already 10 times higher. So it's a really like a growing, expanding market. Why pyrolysis and why to like pyrolyze bioresources or sewage sludge? Because it's solving loads of different problems. Example, like destroying all the pathogens in the sewage sludge, eliminate almost 100% of the organic contaminants, immobilize heavy metals, reduce their bioavailability and toxicity, eliminates micro and nanoplastic. It's a carbon sink, greenhouse gas emission reduction technology. Also, because sewage sludge in a native form is really rich with nutrients, so there's a potential carbon negative phosphorus fertilizer, and pyrolysis is actually already right now today is a deployable and a scalable technology. There's loads of companies out there in Europe and worldwide who's producing large scale pyrolysis units which can be deployed on a wastewater treatment plant and actually pyrolyze the produced sludge. And also there's always these exotic chemicals like flame retardants, which they also calling like forever chemicals. And then example, SEPA is one of major concern about like sewage sludge biochar, then what we going to do with these forever chemicals, because they are actually designed to be stable on a higher temperature, but there is a way how to get rid of these, and then we will come back to this a little bit later on when I will present some results from the project. And then it's always a dark side, and then we need to be like careful, like how we producing the biochar and on which conditions, because we can end up with a product which will have a high concentration of PAHs or volatile organic carbons, or to concentrate all the heavy metals and flame retardants, and then it's not going to do any good for the soil or in the water if you're using for water treatment, and that's the reason why we need regulation. And then in the recent years, when I spoke with different like biochar producers, smaller and bigger companies, we are all agreed, and it's kind of like annoying dealing with the regulators and decision makers about this, because they have always one or two more questions when we think then we addressed all the existing ones. But again, it's a really important thing to have a regulation, because we can end up then everybody will start to burn their waste and then sell it as a biochar. So we really need to clearly define what is biochar and how it should be produced, and then what are the values and the quality what we should achieve before we going into the market. So about the project, so we started this project like mid last year, in 2023. Because this is a feasibility study, so we needed to limit our like objectives, and then try to during that half year to tick as much as boxes as we can. So we defined like 4 objectives. It was like to collect sewage sludge from different Scottish water treatment plants, optimize the production, taking into consideration the different types of the sludge, a different temperature for a pyrolysis, time, and then when we optimize that, to use that sewage sludge biochar in our pilot scale filtration unit at Bowness, and then filtrate like final effluent, recover the phosphorus from the wastewater, and then characterize that and see what is the quality of that biochar, and then to make some suggestions for further use. And so we are now somewhere here in objective 4, when we're trying to find and sort out like with Scottish Water, so when we can potential launch this sewage sludge biochar, and it's not just only taking into consideration the soil and as a fertilizer product, but we exploring different other options as well. And then of course Scottish Water is really interested in this biochar material as solely to solve like different pollutant issue in the water. So we use this biochar also in the meantime to remove like flame retardants, different pharmaceuticals from wastewater, which is a really big topic right now in Scotland, and also heavy metals as well. So how we started, so we as the objective was, we optimized the whole process in the laboratory scale. When we had the optimized biochar in certain conditions, then we collected 100 kilograms of sludge, pyrolyzed it in, or let's say like a pilot-scale pyrolysis unit at in the Environmental Research Institute. This was I think produced around between 30 and 40 kilograms of biochar, and then we put it in this filtration unit and did the approximately a 6 weeks trial in Bowness, and you can see then how it looks like the final effluent which is coming out from the Bowness wastewater treatment plant, and how it looks like when it's actually after the further biochar filtration. And we achieved around 3 milligram per gram capacity, which taking into consideration the scale, and then this was a real wastewater and with low concentration. It's quite remarkable. And also why we used final effluent, just really briefly to explain that. So with the climate change and then the rising temperature globally, so we have more and more problems with algal blooms, and then the right now the regulation says then the final effluent phosphorus content must be 1 ppm, 1 milligram per liter. But because of these warming conditions, now it's starting to become a burden for the water bodies, because it's even in these conditions we can consider this as a high concentration. So we need some additional technologies to reduce that phosphorus level further, let's say at least below 0.1, so at least 10 times. But who's dealing with wastewater treatments, they know then it's not really easy and cheap to remove phosphorus from water. And so we did the characterization for the material. As you can see, the biochar is quite porous, and there's loads of aluminium in it and iron, and then the phosphorus is actually catching on these active sites on the biochar. And this is also really important aspect of the project. Then Scottish Water using loads of different coagulants, flocculants, aluminium and iron based chemicals to reduce the phosphorus level in the wastewater. So the sludge natively containing loads of these metal elements, and then we utilizing this property of the sewage sludge to produce a material which can actually use as a filtration material for phosphorus. We determined the surface chemistry and proposed what mechanisms are happening on the surface at the molecular level, just to understand how this material works. And then really briefly about the quality data. So as you can see, we have a really high phosphorus content. So from the sludge, which have let's say around 3%, with the optimized biochar, we increased about 5, and then when we saturated the biochar during the filtration, we increased further. And then also because SEPA also questioning this purpose, like then how we can use the biochar after the filtration, because it's been in a wastewater for weeks or for months. And then we did the repyrolysis. It's a really quick flash process just to clean out the material, and that process even further increasing the phosphorus level. We have like a healthy ratio of different like macro elements like potassium and sodium, calcium, magnesium, and the quality is we showed them this optimization process producing quite like a high quality biochar, because when we take into consideration the regulation limits for biochar, which is classified as a premium or agro, with the heavy metals like lead, cadmium, nickel, zinc, chromium, arsenic, we are all below these premium biochar regulation. And the only the metal which is sticking out is copper. But again, copper is kind of like sometimes in some soil types can be really like beneficial and essential element. So we are not really worried about this copper level, because it's not seriously and enormously higher, but also it's better to have a higher copper content than example lead or cadmium. Also, the pH content is also lower than actually it's regulated by this standard, and we not detected any PFAS and PFAS like chemicals, flame retardants in the biochars. This could be also related to the optimized pyrolysis process, but also it's related then the sludge was quite clear, because some of the sludge for this biochar been collected in the less industrial let's say territory from Scotland. So it's not all came from, let's say, from the center belt. And then what is the next steps for the project is we definitely need more optimization, at least to include a larger like sample size of different like sludge samples from different wastewater treatment plants across Scotland, because we need a unified model. We already doing this p-fractionation to see like how much let's say phosphorus, so water soluble phosphorus in the biochar, how much will be released in the soil, so how much is available for the plants. The further we will designing now for this summer season to do some soil pot trials. We're really pushing these regulatory barriers with different stakeholders, companies, and of course the SEPA as a Scottish government to trying to address their concerns. And also one of the new perspective what we considering is to use this biochar to leach out P for different like chemical industry, and then after that material which is left, it can be used as a construction fill material, which also will have a similar effect than locking up carbon at the end as we are putting into the soil. And then we have like different like international collaboration through this project will helping like addressing different like quality testing into in the whole project. And then project biochar is becoming quite like a big thing in Scotland. So example, our team won last year the Innovation of the Year award at the Scottish Knowledge Exchange Award ceremony, and this was also related to producing biochar. And then for this project, we also use the bonus facility. So Scottish Water Horizon played a crucial part to achieve these results. And also the king is quite like interested about biochar, and he's using in his gardens. So he when we met with him, he said then he's gonna pass the good word around when he can in UK, and to help us to bring closer this whole technology to the market. So that's me, and that's us with the group at ERI. Thank you.
Brilliant. Thanks, Sabi. That was really interesting there to see the potential for valorizing sewage waste, and something with some great potential environmental outcomes as well. So, and thanks also for the plug for BioSE feasibility funding. We've got a call running at the moment, and I'll mention that a bit more about that after the presentation. So, I'll hand over now to Jonathan Hughes, Managing Director of Pennosan, who's going to speak about fish factory process water upcycling. Jonathan, I'll hand over to you now.
Okay.
Yeah, see your slides now.
Okay, so yeah, thanks very much, Kim, for the introduction. Yeah, so I'm going to talk about work we've been doing at Bowness at the Wastewater Development Centre on the use of chitosans for upcycling fish factory process water and our journey to get there. To start with, I'm managing director of Pennosan Limited, and we are the manufacturers and suppliers and developers of chitosan and chitosan formulations for water and wastewater treatment applications. And I'm grateful for the opportunity to speak today, and for the support we got in the development, both from Scottish Water Horizons, Scottish Enterprise, and I'll mention some other elements within the presentation, including Zero Waste Scotland, in the journey that we took to get here. So a little bit to begin with on the chitosan itself. So chitosan is a wholly natural and biodegradable flocculating agent, essentially, in water treatment applications, and it's produced from chitin fibres, which are present in a whole range of different animal and plant species. It's the second most abundant polysaccharide on Earth, so it's present in insect wings, insect cuticle, fungi, the walls of fungi, and of course shellfish and crustaceans. And it's an insoluble fibre, and the traditional and commercial production process is one of essentially taking the shell material, mainly from crustacean shells, and dissolving away the calcium, and then essentially burning off the protein that's coating these chitin fibres with caustic. Our processes are very different. They're much more environmentally sustainable. We're using industrial biotechnology process, combinations of enzymes and fermentation to isolate the chitin fibres. The subsequent steps are a chemical deacetylation. So essentially, we're removing acetyl groups to expose free amine groups, and under low pH conditions, so below pH 6.5, those essentially still polysaccharide fibres have a positive charge and can act as a cationic flocculating agent, or cationic coagulant, depending on the molecular weight and the size of those fibres. But also they can still operate as natural flocculants up to about pH 7.5. Because of their structure, because of their chemical nature, they have multiple functionalities in addition to just being purely coagulating or flocculating agents. They can chelate metals in water. They're also effective at low concentrations as a defoaming, and also deemulsifying in wastewater situations. We've demonstrated that. Chitosans are probably best known for their fat absorption properties. You can purchase chitosans at Holland and Barrett and take them as a tablet to reduce cholesterol by binding onto fats in the gut, and also have antimicrobial properties under certain conditions. So our Pennosan ourselves are the only manufacturer of chitosans and chitosan formulations for both home and leisure, and for environmental and industrial applications. Our bulk of sales are predominantly in the home and leisure market, where people are looking to move away from the use of chemicals, chemical clarifying agents for swimming pools, swim spas, and hot tubs. And they're seeing the benefits of using Kaisersan, particularly for reducing the not only the dirt you can see, but actually some of the oils and the sweat and etc. that you can't see in these situations. So these are the things that consume sanitizer, consume chlorine, and by removing those using Kaisersan, you can much reduce the amount of chlorine that you're using in swimming pools, and you're not getting that irritating eyes or irritation of the skin effect. So it's a growing market for Pennosan. And in the environmental industrial market, I have to say it's a growing market. We're still looking for to grow that market. We've been in the area for quite a few years now, and more interest in looking at alternatives to chemical flocculants. I mentioned some of the flocculants that are our competitor products at the base of the screen there. So in swimming pools, etc., it's the polydadmax, the polyaluminium chlorides and polyacrylamides, and polyamines and ferric in more industrial applications. I have to say that the Kaisersans are going to be more expensive than the polyacrylamides and ferrics traditionally used in industrial water treatment. But as a consequence of that, we always look for our application areas where there's an added value benefit, a kind of holistic benefit from using a Kaisersan as an alternative to a synthetic product or a heavy metal coagulant. And often there are situations where there may be recirculating water systems where people want to avoid the buildup of residual chemicals within that system. Obviously, Kaisersan is wholly biodegradable, wholly natural, and more often it's areas where people are looking for, or industrial companies are looking to reuse the separated solids, so it's not being treated as a waste, or are looking to convert that recovered solids from a waste material into a potential revenue generating material. So we're always looking for sort of value creation, really, from the separation of the waste, and we've benefited over the last few years from support from such areas as the Seafood Innovation Fund, operated by CFAS, where here we were looking at fishery byproduct. Often there's either in fish or shellfish processing, there's often wash water or waste streams that are contaminated with protein and oils and fish oils, and Kaisersan, being both a fat absorbing fiber and also acting as a flocculating agent, is very good at collecting up protein and oils. And we were able to demonstrate that we were able to produce meals from macerated crab meat, from mollusk processing water, and also from salmon meal. And that was where we started really working with farmed salmon and trout based in Duns, which process, essentially bring in salmon and process them into fillets or processed meals. And in so doing, they generate a lot of essentially processed water, washed down water from their processing. And the volume of that water is quite substantial. It's about 30 meters cubed an hour of this, as you can see on the screen, this fairly pink protein-rich water that they generate, and through the CFAS work, we were able to demonstrate that the Kaisersan is very effective at separating that out, and we were quite interested in looking whether we could upcycle that protein into essentially a feed material, either essentially for animal feed. And we're very grateful to Farn and to work with us on application to Zero Waste Scotland to employ an intern that could work with us both, Jolly Ganawi there that you can see on screen, and obviously you can see from the test work there that the because of the high oil content of the separated solids, essentially the material at farm naturally floats, and you can see the rich pink color there, and the product worked very well. What we were interested in, and where Jolly was able to support us, was actually looking at the regulatory side of this, of the challenge of taking essentially what is currently treated as a waste. Currently, that water is treated with polyacrylamides and ferric, and generated as a sludge, which is then tankered off for anaerobic digestion. And we say, well, actually, no, there's a lot more value in this wastewater in terms of omega-rich oils and fish protein, and what would be the quality of that material. And we were able to do some tracing within the site there of what else engages with that process stream, and particularly doing inventory of some of the cleaning chemicals that are used on site and what might be present within the wastewater stream. And obviously they're all food grade cleaning materials, generally caustic and things like this. So we were able to first of all look at that, and then some of the kind of regulatory barriers to actually upcycling that. And this fits very well with farms' objectives. They sign up to the Quartal commitment to reduce their carbon footprint, and already they essentially the frames that are remaining from fish processing are sold on, so that's no longer a waste stream, and this is obviously the next target for them. So essentially with FARN's support and with Scottish Enterprise funding of a business support grant, we were able to access the Wastewater Development Centre at Bowness and essentially simulate some of the process that's currently operating at FARN. It was quite difficult to bring our process onto site with something that's operating at 13 meters cubed an hour. But we were able, with FARN's support, able to transfer some of their process water up to from the borders up to near Edinburgh to Bowness to actually simulate the process there. So essentially, it's very, very simple. Where we have the process water, and there's an adjustment of pH to bring it into the range, or the water as it's produced up at pH 11, so we're able to bring it down to the suitable range for the chitosan dosing, and the product is Floxan grade product. So able to do a pipe flocculation and then a simulated dissolved air flotation unit to really separate off the protein and oil as a sludge. And currently, as I say, that's where the process stops at the present time at FARN. They tanker off that sludge. They have investigated in the past the use of dewatering equipment to produce a drier sludge, but because that was contaminated with polyacrylamides and ferric, there really was no outlet for that. So the inspiration really of using chitosan is one that you've got something that's essentially fish-based and wholly natural, biodegradable, and food grade that can be incorporated within the sludge. So then we were able to investigate the use of a wave separator that gently dewaters and then presses the sludge to get a dry cake out of that process. So Greg was mentioning earlier on, we were grateful to get some space outside, so we essentially tankered up something 20 or 30 IBCs of the wastewater at the beginning of this year to essentially run the process. We were looking to operate at about 150th of the scale of the process, so a relatively small scale pipe flocculator unit that we had on site there, and a rather simple setup for a DAF unit. But we were able to demonstrate relatively in this first week the essential of bringing the various component parts: the pH adjustment, the pipe flocculation, the DAF, and then the wave dewatering unit all together, and get the various parts operating. And really in the second week of the trials, we were able to really put the whole thing together and start doing some dosing trials, and it worked beautifully. We were able to generate a really nice thickened sludge, over 95% solids recovery. COD was down around 1,000, which was equivalent to what they were achieving with the chemical flocculants on the site at Bowness. So yeah, at Farm Salmon in Duns. And what was really encouraging was that the wave dewatering unit was very effective at dewatering the sludges. We're getting sludges up to 33% dry solids coming off, and it was coming off a bit like biscuit material off the end of the system. So essentially the protein levels, the protein and oil levels that we were getting off about 2 kilos per meter cubed. So that would essentially translate to about 200 tons of salmon protein and oil that one site could produce of that quality, that could then be used in potentially upcycled into animal feed. So yeah, hopefully that's given you a taster of what we were doing, and yeah, just say how grateful we are to the guys up at Bowness for accommodating us and allowing it and supporting the trials, and a particular acknowledgement to Angus Forbes, the environmental project manager at Farm Salmon, who's really been championing the use of hydrosan in their processes. So I'd like to stop there if that's okay.
Brilliant. Thanks, Jonathan. It's such an interesting collaboration, and great to hear about a technology that really looks like it has so many applications. So thanks. I'll hand over now to Mike Rattenbury, who is the Chief Operational Officer at Power and Water, and can speak a bit about their work.
Yeah, thanks, Kim. Just briefly, while I'm pulling up the sharing the presentation, as Kim says, I'm Mike Rattenbury, the Chief Operating Officer of Power and Water. My colleague Sharon's here with me. Hopefully that's come through now. Yeah, so our product is called Seneco, and we combine electrolysis and ultrasound for electrocoagulation. So we essentially generate the metal coagulant directly from a sacrificial anode, which then precipitates the contaminants for solid separation downstream. So we dose the metal into the wastewater stream, bring the metal contaminants together, and then it settles out the metal contamination complex, which then obviously reduces contaminant levels. So I've got a brief video just to show you what our equipment looks like, although we hopefully saw a picture earlier with it on site in Scotland. So this is essentially our process. So our process is skid mounted, and it comes as a package plant effectively. So the 2-chamber reactor at the front, which we're seeing the cutout of now, is the electrocoagulation unit. So you'll see that we had ultrasonic discs there mounted on the outside. I'll come to the reason for them shortly. So the wastewater stream will flow up through the electrocoagulation chamber, and a metal anode will be releasing the coagulant, which typically in a wastewater setting would be iron. So there's a cutaway there to show you how the wastewater moves up over the anodes themselves. So once it's been through that chamber, it'll flow out into the mix tank. So it'll weir over there. So the first chamber of the mix tank is a flash mix for degassing. And then the effluent then will move through into the flocculation chamber with a slow mixer, and then typically it'll come through into a lamella. So you can see there the sludge would be taken from the bottom, and the clean water then would exit on the top. So yeah, that's the typical layout of our Seneco skid. So I mentioned the ultrasonics there earlier. The ultrasonic crystals is what we use to overcome passivation, which was an inherent obstacle with electrocoagulation in the past. We are the only company that has the externally mounted ultrasonics for passivation control. And passivation, as you know, is the corrosion layer that will coat the anode surface. And what that does is it basically creates a resistance layer, which increases the power consumption. So by acting as a cleaning in place mechanism, the ultrasound that we have as part of our system prevents the buildup, and that then in turn maintains a lower power requirement. So what can Seneco do? It has multiple heads. So it's particularly suited for phosphorus, solids, and COD removal in a municipal setting. We also have units in the field in the industrial arena, most notably with Hansen, where we've allowed them in the creation of the cement products to basically close loop their water system so that they don't have to extract or indeed discharge into the local water courses. And then in aquaculture, we have a number of units, again, phosphorus removal, COD removal, solids, using a variety of anodes from aluminium to iron. So our advantages over liquid chemical dosing is there's no requirement for potable water, no safety showers needed because we generate the coagulant from a solid metal plate, which then means there's no need for a storage tank and associated bunding. Quite notably, no additional pH correction, which is certainly a big thing when it comes to liquid chemical dosing and indeed some other competing technologies. And it has a much lower carbon footprint. So just quickly to touch on the carbon footprint, this is a Wastewater carbon assessment that was carried out by McDonald Bentley on a live site that we were quoting for, and that indeed they are putting Seneco in. So you can see their calculations were that a liquid dosing rig would generate about 90.2 tons of CO2 equivalent in embodied carbon and 373.9 ton CO2 equivalent in operational carbon. And that was based on a 20-year operational life. So the total carbon over 20 years embodied and operational was 464.1 tons of CO2 equivalent. And you can see the numbers there for the Seneco equivalent, which reduced embodied carbon by 82%, and the operational carbon pre-alkalinity supplementation of around 51%. We can reduce the total carbon dioxide equivalent by a further 331 on the basis that alkalinity supplementation is not required downstream on our system. The Seneco system doesn't affect the pH of the wastewater in any way. And up at the top right there, you'll see there's a 90% reduction in concrete use. That is primarily due to the fact that our system, the skid-based system, takes up a far, far smaller footprint than some equivalent technologies, and certainly than liquid chemicals. But also because it's skid mounted and there's a spread of load, you could just get away with just having concrete pads in the corners rather than having a full pad itself. So the last 12 to 24 months, we were part of the Scottish Water Horizons trial, which was fantastic for us. I'll touch on that in a second. Northumbrian Water have taken some systems which are going live on their site shortly. Wessex Water, again, they'll be live in the coming weeks. And Yorkshire Water have actually placed a significant number of orders, which will be rolled out over the coming months up to the end of this year so that they can meet their AMP7 requirements. So this is a picture of the Ofwat Innovation Challenge, Breakthrough Challenge, which is currently ongoing at a UU site. You'll see Seneco there on the left-hand side. The second rig is a traditional chemical dosing rig, then Kalina, an evergreen system, and a hydro industry system. To date, the results have been overwhelmingly in our favour, including when compared to liquid chemical dosing. So, case study. This is the work that we did at the Scottish Water Horizons trial in Bowness. So this is a picture that is pretty similar to the one that was showed earlier. The objectives here were for an opportunity for Scottish Water to see the Seneco process operating in a real-life setting. It also gave us the opportunity to optimize dose settings for pea removal, using iron plates in particular, considering different influence. So we set this at various points of the wastewater treatment sort of cycle. And it was also an opportunity to extend our real world data and performance analysis for the Seneco equipment. So we were able, as I say, to show it on a range of influence. And in particular, while it wasn't the focus of this particular investigation, we did find that the doses applied to the screened crude and the post-primary wastewater for pea removal also showed very good COD and TSS removal. And there's a graph just showing sort of some of the P limits that we got down to compared to the dose ratio. So we were able to reach a soluble reactive phosphate levels of below 0.05 milligrams per litre. And the effluent target of less than 2 milligrams per litre total phosphorus was readily achieved at the site. And a much lower effluent concentration of 0.2 milligrams per litre total phosphorus was actually achieved. And quite strikingly for us, whilst we knew that we were certainly very competitive in terms of power and therefore power costs, a total cost of £65 was our running costs for the 12 weeks of operation, which were even more positive than what we had anticipated. So yeah, that was our experience at the Scottish Water site, and yeah, that's the end of the presentation.
Great. Thanks very much, Mike. It's good to hear more about your technology and your experiences working with Scottish Water Horizons. So that's really useful. Thank you. Just going to share my screen again here. So we're going to turn now to the Q&A. I've got a very sort of generic question here, first of all, for Greg. What would you say would be the first step for someone thinking about accessing Scottish Water Horizons facilities and the voucher scheme?
Yeah, that's a good question. I suppose the key is if you've got the technology, if you've got a piece of equipment, the key question for a trial is what are you hoping to achieve, and that's something that we can sort of assist in for a goal for what your output of your product would be, I guess. So if you're not at a stage that you're ready to trial, we're more than happy to have a discussion and sort of point in the right direction to get you into that state where you're ready to trial. So I would say there's nothing hard and fast if you've got something that you're looking to trial. We're open and ready for business to accept you at any stage, really.
Brilliant. Well, that's great, Greg. I'll share both yours and my contact details at the end of the webinar, just so that anybody can reach out to either of us to progress things there. So thanks very much. Mike, I've got a couple of questions. Sorry, not Mike, Jonathan, rather. I've got a couple of questions for you. The first is, what other process wastewater streams have chitosans been used to separate? And you were talking about the fish processing wastewater, but are there other applications that you're aware of?
Yeah, so certainly within we look at both the industrial and the environmental applications. So in environmental applications, then there's construction water, where regulations are getting a little tighter on what chemicals can be used in those applications and what can be released into the environment. So there's a great interest in looking at natural and biodegradable alternatives, and I think chitosan works very well in those applications. Also in environmental, then we're currently involved in some work on actually reducing and removing algae from lakes and ponds, and potentially utilizing that algal dewatered algal biomass as a compost, for which potentially could be a phosphate rich compost. And then in industrial areas, we're looking at areas such as extraction of botanicals, where there's a waste stream, again, where people are looking to use a natural product for separation. And in actual aquaculture as well, we had a very interesting project where we were separating the aquaculture biosolids, the feces, from both recirculating aquaculture and also from open pen aquaculture, and converting that in fact into a feed, and that was then being fed into ragworm for recycling into animal feed.
Great. Thanks, Jonathan. That's so a wide range of applications then, for sure. And just really speaking in terms of Pennosan, what are the next steps for you now for taking things forward?
Yeah, certainly. We there's two parts of the business. One part of the business is on the manufacturing side, and what we attempted to do is to develop the supply chain for chitin material and shell material in the UK, and we're working with shellfish processors all around the UK to process their shell and actually deflesh and recover the meat from that shell using chitosan and converting that into a feed, in order to have a steady supply of shellfish into our processes for chitosan manufacture. So looking to scale up that, but we have to do things in parallel, really developing the market for chitosans, particularly in water treatment applications, and in order to convince investment in chitosan manufacturing facilities.
Great, thanks. There's a clear runway there for you then, a bit of a
absolutely, yeah,
a direction, which is great. So we've got quite a number of questions here from Isa too. Some of them quite technical, and we're running short of time here, I'm aware. So perhaps it's best if I contact you offline and we can pick up on some of these. So I think we have a few different stakeholders that might be able to help you with those. So I'll drop you an email after the webinar and we can pick up on those. Question from Neil Robertson. How does chitosan in post-whiskey co-product, post-anaerobic digestion, ultrafiltration, dewatering compare to polyacrylamide in relation to PAS 110 accreditation? Who wants to take that one? I guess that would be you again, Jonathan, perhaps.
Okay. So certainly we have certainly been working with post-whiskey byproduct and demonstrating that chitosan is effective in separating the biosolids from that. I'm afraid I wouldn't be able to give you an answer regarding the PAS 110 accreditation, but I'm very happy to have a discussion offline with you on that if you're able to share your contact details.
Sure, I can connect you both actually after the webinar. We can do that. So does anyone else have any questions for any of our speakers? There's one from Ben Harrington here from Ecocentric Energy. I'm having problems accessing the application. Is that accessing the webinar, Ben, or I'm not sure. Perhaps you want to say a bit more if you want to come off mute and explain a bit further.
Is that the application form for the innovation voucher?
Maybe it's a form.
Yeah.
Well, yeah, good one. I think that maybe a missing letter there. So
I can send the link to yourself, Kim, if you can send it on, and
yeah.
if not, Ben, if you get in touch with me on my email address, and we can sort that out for you.
Good. Okay. Thanks. They're coming thick and fast now. Application form. Okay, so Ben's just clarified it. That's what he was after. Another one for Pennosan, actually. You mentioned that chitosan is more expensive than traditional flocculating agents. How does the material compare in terms of production and broader sustainability, for example, CO2 emissions from production? Is that one you're able to answer just now, Jonathan?
Yeah, I think certainly the traditional flocculating agents will be obviously manufactured on world scale plants, so there'll be some economies of scale there, but essentially petrochemical based and involve cracking and production of the raw materials from ethylene. Certainly in the case of polyacrylamides, there's a lot of chemical steps and energy used in the production of traditional flocculating agents. With chitosan, it's the opposite. Essentially, at the present time, shellfish is transported as wet shell large distances, disposed of either to landfill or to incineration. So there's a large actual impact of disposal of shellfish shell, and our process of macerating that shell, extracting the chitosan, which is in its natural form, is essentially is a net zero processing in comparison to disposal. So it is certainly beneficial from that point of view.
Thanks, Jonathan. So unless anybody has any further questions, I'll just move on to chat a little bit about the iBioIC feasibility fund that I mentioned earlier. So we have a call open at the moment, just a couple of weeks to run on that. It closes on 3rd of June. Up to 30,000 of grant funding available for industry-led collaborations with Scottish academics. 50% match funding has to be provided by the industry partner, but that can be cash, in kind, or a combination of both. As I say, the call closes on the 3rd of June. You can use the QR code there to find out more about the call documentation, or email our projects team directly to get that sent across to you. So yeah, all that remains now is for me to thank all of our speakers and everyone that's worked hard behind the scenes to bring this event to fruition. So thank you. Contact details for myself and Greg are on the screen there. If you have any questions about Bioeconomy Cluster Builder or iBioIC, then please drop me a line, and Greg, I'm sure, will be happy to pick up with you about any questions you have around Scottish Water Horizons and the scheme that they're running at the moment. So thanks to all of you for your time, and I hope you enjoy the rest of your day. Thank you. Bye for now.